Hey guys, Mr. Burns here with your video for lesson 5.3, Solving Systems by Graphing. By the end of this lesson, I want you guys to be able to determine the solution to a system of equations by graphing. Starting there at the top, it says the solutions to a system of equations is the points where the two equations intersect. For linear equations, the two lines may intersect once, infinitely many times, or not at all. One method for finding the intersection point of two lines is to graph the lines. This method works well when the intersection point has integer coordinates. Solving systems of linear equations by graphing. Step 1. Convert both linear equations in the system to slope-intercept form. So remember that slope-intercept form is y equals mx plus b. That's your linear equation, all dressed and ready for prom. Step 2, graph both equations on the same coordinate plane. So remember, it takes 2 points to make a straight line, 3 or more to verify. Step 3, determine the point of intersection. Okay, and that's where the two lines intersect. Step 4, it says verify that the ordered pair is the solution by substituting the x value and y value into each equation in the system. So here we've got example number 1. Make sure you guys read it, okay, and study it, because it's going to show you what to do and how to do it and how to verify it. Okay, it's going to show you steps 1 through 4 if you take the time to pause the video and look and read. I'm going to go ahead and we're going to go to the next page. At the top there, it says when the solution to a system of equations does not have integer coordinates, you can approximate the non-integer solutions using the graph. Graphing calculators or online technology can be used to find a more exact value of the solution. Additional methods for solving a system of equations will be used in the future, especially when you guys get into algebra and algebra 1 at the high school especially. You'll examine these linear equations even more. Again, on example number 2, it says approximate. So that's a kind of an educated guess, right? So an approximation. So it says approximate the solution to the system of equations at the right by graphing. So again, okay, it says graph both lines on the same coordinate plane. Okay, and then over here it says estimate the value of the x and y coordinates. That's what they're doing here. Okay, and remember those squiggly lines mean approximately equal to. Okay, so it's a ballpark figure. All right, let's take a look at your tiered worksheet. Okay, so here we are on the tiered worksheet for numbers 1 and numbers 2. Your instructions are, it says solve each equation, solve each system of equations by graphing. If the system does not have exactly one solution, state whether it has no solution or infinitely many solutions. Remember, in order for it to have one solution, the lines have to cross. If it has no solution, those lines are parallel, okay, which means they never cross. And the last one, infinitely many solutions, that's where both of the equations are the exact same. Okay, so I'm going to zoom in a little bit for numbers 1 and numbers 2. That way you can see what I'm doing and plot it exactly. So here we go with number 1. On number 1, you've got y equals 2x minus 3. And then you've got the second equation, y equals 1/2 x plus 3. In the box there, okay, so in this box, it says start with the y-intercept, then plot 2 to 3 additional points using the slope. So here we go. Number 1, let's go ahead and list the y-intercept and the slope for both of these equations, and then we're going to plot some points. Okay, so for number 1, the y-intercept is -3 or minus 3, and the slope is 2. Now I'm going to change the slope into an improper fraction. So since our slope is a whole number, I'm going to change it into an improper fraction by putting a 1 underneath it, and you'll see why here in just a second. Okay, so my slope is 2 over 1, which is the same thing as 2. Okay. Now for the second equation, y equals 1/2 x plus 3, the y-intercept is 3. and the slope is 1/2. So it's already a fraction. Let's go ahead and plot our equation on the line. So for the first equation, our y-intercept is -3. So from the origin, I'm going to go straight down to -3. From there, okay, I'm going to go ahead and start with my slope. So remember, 2 points to make a straight line, 3 or more to verify. So I'm going to put 3. So from that first point at -3, I'm going to go up 2 and over 1, which is right there. Then I'm going to go up 2 more, over 1. There's my third point. 4 points, up 2 over 1. Okay, and there's my first set of coordinates. And then I'm going to go ahead and try to draw myself as straight a line as I possibly can. Okay, so there's my first line. All right, so for the second line, I'm going to choose a different color. Let's say red. And my y-intercept is 3. So I'm going to start at the origin, and I'm going to go up 3 spots. 1, 2, 3, and there's my first point. Now my slope is up 1 over 2. So from that very first red point, I'm going to go up 1 and over 2, which is right there. That's my second point. Remember, 2 points to make a straight line, 3 or more to verify. So let's plot 2 more. Up 1 over 2. Up 1 over 2. And just for the heck of it, up 1 over 2. And I'm going to go ahead and connect those dots. Now, what you might want to do is get yourself a ruler or some form of a straight edge, okay, and draw your line. But there's my second line. So it looks like both of these lines cross or intersect at this point. I'm going to put a box around it. Okay, so it looks like it intersects from the origin. I'm going to go, and it looks like it intersects at 4 and 5. So that looks like that's the proposed solution. Okay, is 4, 5. So what we're going to do now is we're going to go ahead and verify that by plugging the coordinates 4 and 5, okay, into the equations to see if it works out. Okay, so see if they equal each other. Here we go. Let's verify. Go down to the bottom. So we believe that the proposed solution is 4, 5. So we're going to go ahead and write that down. Choose a different color here. I'm going to choose, that color. So 4, 5. And we're going to plug those coordinates, those values for the coordinates, into the equations. So my value for y is 5. And my value for x is 4. And we're going to go ahead and simplify this equation. So I'm going to scoot up just a touch. Dun, 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 dun. Okay, and I'm going to write this one over, over here. So we're going to go 5 equals 2 times 4 minus 3. Let's go ahead and solve this, or simplify it. So 5 equals 2 times 4 is 8, so 8 minus 3. And then 5 equals 8 minus 3, that's 5. Okay, does that work? Yes, it does. So far, 4, 5 is a solution, but now we have to plug it into the second equation. Okay, so we've got a value for y, which is 5, and a value for x, which is 4. Okay, we're going to simplify this equation. So leave the 5 alone. Half of 4 is 2. 2 plus 3. And 5 equals 2 plus 3, and that's 5. So guess what? That is, in fact, the solution, because when I substitute the values in, okay, to both equations, I come up with the same number on both sides of the equal sign. Okay, let's jump to number 2. Okay, so here we go with number 2. We have our two equations, y equals 3x plus 5, and the second equation is y equals x plus 1. So just like before, the y-intercept for the first equation, so the y-intercept is positive 5. Okay, and the slope for that equation is 3 over 1, or the same thing as 3. All right, let's see. For the second equation, I'm going to choose a different color here, darker looking green. Okay, and then for the second equation, so for this one, my y-intercept, okay, is 1, and my slope, okay, there is no number in front of the x term, so if there isn't one, guess what your slope is? It's 1 over 1, so 1, 1. All right, so that's our slope. Okay, let's go ahead and graph these, and I'll use the same colors. Okay, so for the very first equation, my y-intercept is 5. So from the origin, I'm going to go straight up to 5, right there. My slope is 3, 1. So from that very first point, I'm going to go up 3 spots and over 1. Now I'm running out of room, so I can go the opposite direction too. So in this case, I'm going to go down 3 and over 1, down 3 and over 1, down 3 and over 1. So there are my points. Let's go ahead and draw the line. Okay, there's that line. Let's go ahead and draw the plot points for the other line. So my y-intercept on that one is positive 1. Okay, and then my slope on this one is 1, 1. So up 1 over 1, up 1 over 1, and up 1 over 1, up 1 over 1, and so on and so forth. Up 1 over 1. So I'm going to go down 1 over 1, down 1 over 1. Hey, look at that. There we are. There's our point of intersection. So let's go ahead and draw our line for this one and then write our solution down. So it looks like our solution, okay, is from the origin -2 and -1. Looks like that's the point of intersection. So let's go ahead and verify it by plugging it into our equations, okay, and see if it works. Hey, everybody say hi, Mrs. Burns, or Mrs. Burns, say hi to everybody.
Hello, everybody.
We're studying math, Mrs. Burns. What do you think about math?
It's awesome.
All right, here we go. Let's check our solutions, guys. Okay, so here we are with our equations written down, and let's go ahead and plug in our values for the x and y coordinates. So in the first equation, we got y equals 3x plus 5. So let's plug in our values. So we've got -1 equals 3 times -2 plus 5. Let's go ahead and simplify the right-hand side of our equation. So we got -1 equals 3 times -2 is -5, or -6 plus 5. -1, leave it alone. And then -6 plus 5 is -1. So that checks, right? So that works in that equation. Let's check it with the second equation. So we've got -1 equals -2 plus 1. Got -1 equals, and then we go -2 plus 1. That's -1. So guess what? That checks as well. So guess what? That is, in fact, the solution. Okay, let's go ahead and jump on to the back page. Yippee-ki-yay. Okay, so on the back page, for numbers 3 through 6, your instructions are: solve each system of equations by graphing. If the system does not have exactly one solution, state whether it has no solution or infinitely many solutions. So here we are with number 3, and again, what I'm going to do is I'm going to zoom in, okay, so that way I can plot my points and so on and so forth, okay, and set up my so you guys can see it a little bit better. So here we go, number 3. I'm going to zoom in and get working on it. Okay, so with number 3, you've got two equations, y equals 3x plus 1, and then the second equation is y equals x minus 3. So the first thing I'm going to do is indicate the y-intercept, okay, and the slope for both of these equations. So for the first equation, okay, our y-intercept, okay, is 1, and the slope is going to be 3 over 1. For the second equation, okay, the y-intercept, okay, is -3, and the slope, okay, is just x, or 1 over 1. All right, let's go and plot ourselves some points. So for the first equation, the y-intercept is 1. So from the origin, I'm going to go up 1 spot. There we go. My slope is 3, 1. So I'm going to go up 3 over 1. Up 3 more over 1. Up 3 more and over 1. And there you have her. Pitter patter. Okay, let's go ahead and plot the points for the second line. So my y-intercept is -3. So from the origin, I'm going to go straight down. Bada boom, bada bing. My slope is 1, 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. So on and so forth. Okay, and let's go ahead and see where this intersects, where these two lines intersect. Okay, so there's our other our other line, and it looks like it intersects right here. Okay, so it looks like it intersects at -2 and -5. Okay, so let's go ahead and check that solution. So the first equation is y equals 3x plus 1. And actually, let me do this. I'm going to erase that. And use the other color. So y equals 3x plus 1. And let's go ahead and substitute our values in. So we've got -5 plus 3 times -2 plus 1. Let's go ahead and simplify the right-hand side of this equation. So we've got -5 equals 3 times -2, which is -6, plus 1. And then we've got -5 equals -6 plus 1, which is -5. So that checks. Now let's go ahead and substitute the values into the second equation. So we've got y equals x minus 3. So the y value is -5, equals the x value, which is -2, minus 3. We've got -5 on the left-hand side of the equal sign, and then -2 minus 3 more is -5. So guess what? That is, in fact, the solution to this system of linear equations. Okay, let's check out number 4. Okay, so on number 4, we've got the two equations. Y equals 1/2 x minus 5, and the second equation is y equals -1/4 x plus 1. So here we are with the y-intercept and the slope. So for the first equation, my y-intercept, k, is -5. And my slope, k, is 1/2, or 1/2. For the second equation, okay, my y-intercept in this case is going to be 1, and my slope is going to be -1/4. Let's go ahead and plot these points. Okay, so for the first one, I've got -5. So from the origin, I'm going to go down to -5. That's my y-intercept for the first equation. The slope is 1, 2. So from that first point, I'm going to go up 1 and over 2. Up 1 over 2. Up 1 over 2. And up 1 over 2. Okay, go ahead and connect those dots. Okay, and then let's go ahead and, excuse me, plot points for the second line. So my y-intercept is +1, so from the origin, I'm going to go up 1. And then my slope for this one is down 1 over 4. So down 1 over 4. Down 1 over 4. Oh, look at that. There we go. Let's go ahead and connect those dots, shall we? Okay, so there's the second line. And it looks like it crosses at 8, -1. So that might be a that might be a possible solution. So 8, -1. But we're going to check our answer and verify, okay, with those coordinates. Here we go. So if the first equation is y equals 1/2 x minus 5. Let's go and plug in our values. So we've got -1 equals 1/2 times 8 minus 5. Got -1 equals, what's half of 8? That's 4. So 4 minus 5. And then -1 equals 4 minus 5, which is -1. Okay. So for the second equation, let's go and plug those values in. So we've got y equals -1/4 x plus 1. Plug in our values. So we got -1 equals -1/4 times x, which is 8, plus 1. Got -1 equals, what's -1/4 times 8? Hopefully, since you guys are all in, I believe, 8th grade math, you should be able to use our calculators, okay, and understand how to use your calculators. So what's 1/4 of 8? So what's 8 divided into 4 equal parts? Well, that's 2. But since it's a negative times a positive, it's negative 2 plus 1. So you got negative 1 equals negative 2 plus 1. That's negative 1. So guess what? This solution checks, and that is the solution. It is, in fact, the point of intersection of these two equations. Okay, number 5. Okay, so on number 5, we've got the equations y equals 2x plus 3 and y equals 3 plus 2x. Let's go ahead and list their y-intercepts, okay, and their slopes. So for the first one, okay, our y-intercept, okay, is 3, and the slope is 2 over 1. Let's go ahead and check the second equation. So in the second equation, my y-intercept is 3, and my slope, okay, is 2 over 1. Well, let's check this out. So math, what makes math easier is noticing patterns, okay, and recognizing what these patterns mean. So if you look at these two equations and you look at the y-intercepts are exactly the same and the slopes are exactly the same. So what can you say about these two equations? You got it. They're exactly the same equation. So if they're exactly the same equation, okay, the number of solutions you're going to have is infinitely many. So the solution is going to be infinite. Why? Because this is going to be the same line. So let's go ahead and plot some points. So let's see. So my y-intercept for the first equation is positive 3. So from the origin, I'm going to go up 3 spots and plot that point. My slope is 2, 1. So when I plot this point, it's up 2 over 1. Up 2 over 1. Up 2 over 1. Let's go ahead and connect those dots. I'm going to try to do this as best as I possibly can. Yeah, that's pretty slick. Okay, so there's my first line. Let's go ahead and plot the second set of points. So my y-intercept is 3. So from the origin, I'm going to go straight up three spots. Well, guess what? There we have it. So my slope is 2, 1. So up 2 over 1. Up 2 over 1. Up 2 over 1. When I connect those green dots, guess what happens? Again, it's exactly the same line. So again, there's infinitely many solutions because these are the exact same lines. Okay, let's check out number 6. Okay, so on number 6, your first equation is y equals 1/3 x plus 4, and the second equation is y equals 1/3 x minus 2. So on this problem, let's go ahead and do the same thing. So for the first equation, my y-intercept, k, is 4. And my slope, k, is 1/3. And then for my second equation, okay, the y-intercept is negative 2, and the slope is 1/3. Now, again, recognizing patterns, right, and applying those patterns to this situation. So you'll notice that the y-intercepts are different, but the slopes are exactly the same. So if you have the same slope, but different y-intercepts, you're going to have parallel lines. And if you have parallel lines, guess how many solutions you're going to have? None. Why? Because parallel lines never cross. They never touch. Okay, they're always the same distance from each other. But just to prove a point, let's go ahead and plot our points. Haha, pun intended. Okay, here we go. First line. So from the origin, my y-intercept is 4, so I'm going to go straight up to 4. Bada boom, bada bing. My slope is 1/3. So from that very first point, I'm going to go up 1 over 3, up 1 over 3, and up 1 over 3. Okay, draw our line. Connect the dots. Bada boom, bada bing. Okay, let's go ahead and plot our second set of points for the second equation. So from the origin, I'm going to go down 2, because that's my y-intercept for the second equation. And then my slope is 1/3, so up 1 over 3, up 1 over 3, up 1 over 3, and I'm going to connect those dots. So there you have it. Okay, you got parallel lines. No solutions, none, nada, zilch. Okay, pretty straightforward, pretty simple, pretty easy. If you guys have any questions, make sure you come and ask the teacher, or make sure you go and ask the teacher. And if you have any questions, and the teacher's unavailable, come and ask me. I'll try to help you as much as I possibly can. Other than that, that's all I got. Mr. Burns, outy pouty.